Let's test a hypothesis about a mean. In the previous lesson on confidence intervals, we looked at this problem on page 145 in the course packet, where we work in some bakery and we produce loaves of bread that have 1 pound supposedly of bread inside. And we drew a random sample of loaves from today's production. And earlier we had to find a 95% confidence interval. Now I'm going to show you how to do this with do a similar problem with hypothesis testing. So instead of just finding a confidence interval, let's test an explicit hypothesis that the mean weight of our bread is 1 pound. Now notice that none of these loaves of bread weigh exactly 1 pound. There's one that's 1 pound within 2 decimal places, but chances are, if you go further out, it's not exactly 1 pound. So is it plausible that this machine is really putting 1 pound of bread in? That's the real question we want to answer. Let's go over to Excel for a second. And this was the Excel spreadsheet that we had up last time when I taught confidence intervals. Let's start out by stating what the parameter is here. So the parameter is mu, and we're going to say mu is the true mean weight in a loaf of bread. So if we could do a complete census of all the loaves of bread that we produce today and find the average, then we would know mu. But we haven't done that. Instead, what we've done is just measured a random sample of 12 loaves of these bread. And of course, the mean is not exactly 1. So the question is it plausible that if we could have done one of these censuses and measured every loaf of bread that we produce today, would the mean equal 1? That's what we're trying to evaluate. So let's go state that hypothesis explicitly. So the null hypothesis is that mu is equal to 1. The alternative is that mu does not equal 1. So one way of writing not equal is to say greater than, less than. So mu not equal to 1. Again, I'd prefer if you use a not equal sign, but since I can't really insert a not equal sign here, I'll do the greater than, less than, which is what computer people often do. Okay, now to test this hypothesis, the easiest way is to do it in Excel. Now, SPSS. So let's go back to SPSS. And to do this test, we're going to go into Analyze, Compare Means, and One Sample T-Test. Now, I should note that the same assumption that we had to make when we computed a confidence interval applies here as well. We need a normal population distribution since our sample size is only 12. We checked that back when we did our confidence interval. So, it's plausible we have a normal parent population, so we'll just go with it here. To use this t-test, what we're going to do is copy weight in, and then we need to set a test value. So the test value is sometimes called the reference value. Siegel calls it the reference value. It's the thing sitting in your null hypothesis. So the reference value in this case is 1. So once we've copied the weight variable in and set the test value to 1, we just go hit OK. And this is the output that you get. And you'll see that the output looks a whole lot like what we had from Explore. It gives us the n of 12, gives us the mean, the standard deviation, the standard error. Refer back to the video on confidence intervals to see how these numbers are all related. Now down here, notice first off that the test value is 1, and we get a sig two-tail. So the sig two-tail is 0.068. That indicates that I do not have a significant p-value. So since 0.068 is greater than 5%, I cannot reject the null hypothesis that the mean is 1. And I stated that back in the Excel file. So I have no evidence to reject that null hypothesis that the mean is 1. Now, let's go look at this in Excel. So if I had to do this in Excel, how would I do it? Well, going back to Excel, here's everything that we did before. Let's find the t-statistic. So the t-statistic is equal to the sample mean minus the reference value. So the reference value is 1 divided by the standard error. So the standard error is up here. And if I hit enter, you'll see it's 2.02 something or other. Now, this shows up in my SPSS output. Let's go take a look at that. And so down here is your t-statistic. They just call it t, 2.021, and that's exactly what we computed over here. Now to find the p-value, in Excel, we have to use the tdist function. So tdist, and we have to enter in the t-statistic. Then we need the degrees of freedom. Now recall from the confidence interval lecture, the degrees of freedom are always the sample size minus 1, so we get 11 degrees of freedom. And then it says how many tails do we want? Well, we want 2 tails. And if you hit enter, you're going to get 0.0682 something or other, 0.06826. So if we come back to Excel, SPSS, notice we get exactly the same value. So that's how we would do it in Excel. Notice there's a lot more steps. Now, an alternative way of testing this is to use something called the confidence interval approach. So let's go back up in my output to the confidence interval that we computed in SPSS. Now, whenever the reference value is contained in that confidence interval, you can't reject the null hypothesis. So notice that 1 sits in this confidence interval. Therefore, 1 is a plausible value for the mean. If the confidence interval had not covered the reference value, that would indicate that we could reject the null hypothesis. So either approach, the confidence interval approach, checking whether the reference value is in the confidence interval, or doing the hypothesis test with the single sample t-test in SPSS or Excel, is a legitimate way of testing this hypothesis. So that's how we test hypotheses in SPSS and Excel.